Hello, everyone. I'm sort of surprised because from the backstage I only saw those tables, so I was really sort of surprised to see it's already prepared. Anyway, it's nice to see you again this year. Enjoy Portland, beautiful weather, and US in general. This talk that I'm making today is sort of special because for most of my time, all the talks that I was making, they were all about JavaScript, React Native tools, releases, and the general experience working with native modules. Today, I'm here to talk a bit about ReasonML, our experience building that, and basically to tell you what we've been after for the past year. So before we begin, just a quick introduction. I'm Mike, and surprisingly, I'm a software developer using React in particular. I'm on a React Native team, doing releases, work around that, helping with general maintenance, and some work around command line tools as well. So 3 years ago, I founded CodeStack, which is a consultancy with a mission to help developers like you launch their products on every platform at the same time. That's 3 of us at Chain React right now with Anna and Adam. We have a booth upstairs. You can hit us up for some nice t-shirts if there are any left, stickers, and just generally chat about React Native. And if you got any questions about ReasonML, about my talk, feel free to hit us up there. So before we start, let me ask you a question. How many of you have ever heard or used ReasonML before? OK, so there is quite a few. Those who didn't raise your hands, don't worry, we got a few introductory slides to go through reasonable basics so that we all know what's the talk going to be more or less about. So ReasonML is a statically typed language that is based on more or less 25 years of OCaml experience, and research around multi-platform development. It has a very powerful type system built in with type inference. And so that means that you don't have to write types everywhere you're writing your code. Sometimes the compiler will just infer the types for you. And the other key design point of Reason that I'm really excited about is that ReasonML is familiar to JavaScript developers. And I sort of experienced that myself because I used to I used to learn OCaml at my university. And I almost failed the subject because of being unable to write algorithms in OCaml. It was just too hard for me. So when I first experienced ReasonML, I was really excited because many things that I couldn't understand otherwise became easy to understand straight away. And obviously, it has a very, very powerful build system that makes build times very fast. Especially the incremental builds are so fast that sometimes you can't even notice that it rebuilt in the meantime. And so just a quick introduction to the syntax itself. This is how you can define a type declaration for something that you would call an object in JavaScript. This is a record in ReasonML. And in this case, it's a person that has a name and a surname of type string. Then you define, create an instance of that record. In this case, it's me with my name and my last name. And for example, here's how you can create an arrow function that accepts this person as a first argument. And what it does is it basically console logs the name. And this is something very similar to spread operator in JavaScript, which is basically creating another instance of that person. As you can see, type is missing here. It's automatically inferred for you, and it's obviously person. So more or less, this is very similar to JavaScript. I picked those examples on purpose just to show it's not a whole new experience for you. Obviously, there are different things because it's a different language all in all. But in many cases, you will find yourself already at home. So let's talk about FFI in ReasonML, which is a foreign function interface. So FFI is a mechanism by which one program written in this case in ReasonML can call routines or make use of services that were made in other language. So in case of Reason, this is about accessing JavaScript code through something that we call a binding. And bindings are just type definitions made around JavaScript code to allow you access through types and guarantee sort of type safety when you are dealing with a JavaScript world. And the following example will demonstrate how you can actually create a type definition for a math SQRT function in JavaScript. So what you do at the beginning is that you create external function of name sqrt, and this is how you will be calling that function from ReasonML, and then you basically call it as a next line. Next, what you do is you have to define type definition. So you have to actually think about the API declaration of the JavaScript function, in this case, mathsqrt, and think what would be the most appropriate type definition. In this case, it's a float, and it returns float because that's essentially how it works. And as a last step, you use some bucket script magic. In this case, you annotate this function, letting the compiler know that you just want to call a global function math.sqrt with the values that were given from the ReasonML world. Now, I'm not going to be diving into details how FFI works itself. If you'd like to learn more about that, I strongly recommend you to listen to Jared podcast from ReasonTown. When I first started writing ReasonML, I didn't understand FFI at all. It was like a magic for me. And after listening to this podcast, I immediately got a full understanding of how it all works. So it's the best resource right now where you can learn how FFI works. So the reason I brought FFI was to actually think about what writing bindings for JavaScript libraries gives us. So writing bindings to existing JavaScript libraries is great because it gives us an ability to take a step back and think about API decisions that we made in the past. And so you can think of it, how would your library look like if there was no previous experience, no user base, and no legacy code to support? And that's great because that opens up your mind and allows you to think big, like how the future API and future versions of your library could look like. And so a great example of that is ReasonReact, which is bindings to React in ReasonML. They are just bindings, but if you look at it closely, you will realize it has a different philosophy in a few places, including, for example, built-in state management, different lifecycle methods, and as you can see from this snippet, functional render. If you actually go ahead and check the future of React, that repository that has proposals about future versions of React, you'll see that some of the features that are already available in Reason are actually pending proposal to be discussed. So I'll try to mention some of those differences as we go along. So all these things mentioned previously, all together, bring a lot of exciting improvements to the React Native ecosystem. So let me ask you this question. What would your ideal React Native workflow be like if there were no constraints and no prior art to support? Just think about it for a second. I'm sure that there are things that you thought about that are fundamentally different from what we currently have in React Native, or what we say is the best practice in React Native. Thinking about them without all the JavaScript context makes you come up with observations you'd never had otherwise. If you are a full-time conference attendant, and if you go to many conferences a year, it's probably not the first time someone like me stands in front of you and is about to say that ReasonML is great and you should use it, right? Like I myself can remember, for example, Ken Wheeler from many talks around ReasonML, pretty exciting. Yet somehow, native development with Reason is still behind. When I was chatting with people around the community, with maintainers of BS React Native in particular, they told me that there's maybe just a bunch of people using React Native in Reason. And that got me thinking, why is that? What's so hard? Or what is the problem that makes Reason not that popular in React Native? So first I asked myself, and I started thinking about my journey. When I first started using Reason, I didn't finish it. I stopped somewhere in the middle, you know? Figured there was just too many tools to set up, too many different things that I didn't know about to get up and running to build a very simple mobile experience. So a few months later, I was encouraged by my friend Mateusz that works with me, and he sort of encouraged me to give it another go. And by the way, if you don't know Mateusz, it's that guy who said on Twitter that we all be writing Reason in 2017. That was obviously overestimated, but I think it's going to happen eventually. And so the next time, I passed through all the steps. I did some reverse engineering. I looked at the source code. I dealt with missing documentation and all that stuff. I've been there. And once I started writing apps with Reason and React Native, I got so excited that I decided to do everything I can to make it an exciting experience for everyone else. And so just to give you an idea how the getting started with React Native and Reason looks like right now, it's the first step from GitHub. And by the way, sorry for a bunch of white slides now, but it's a copy-paste from GitHub. You have to install some dependencies. Chances are you already have a few of them. So you go to next step. You create some files. You configure them. You don't really know what they are doing. Then you add some scripts to your package JSON, and more and more and more and more. And you're sort of done at the end. And chances are that after 2 slides or 3 slides that I showed you, you sort of had no idea what you are already doing and just started copying, pasting stuff all over. And don't get me wrong, because all those steps that I showed you are like 100% legit. They are like reasonable. You should do them eventually. Problem is, when you are just starting, you really have no idea what they are. So it just feels weird to set them up. And unfortunately, as soon as I got started, another problem that I had was missing documentation. So in other words, it's slack. In my particular case, what I was doing, I was trying to investigate animated API and how to use it. And so animated API is very tricky. I mean, it's very hard to understand at the very beginning. At least it was for me. And trying to understand it at Reason was even harder. So one may say that Reason are just like React Native and Reason, these are just bindings. So eventually the API is the same. So why couldn't I just go straight to React Native documentation, learn, animate it, and just do the same steps? Problem is, it's not the same. And that's the biggest problem, because you don't know where the difference is. And that makes you stuck all over the place because you don't really know which API is different. So ended up reverse engineering files like this, which is an interface file in Reason. And it's like a public declaration of your API. So if you have a file that has hundreds of functions, the interface file is what defines what is visible outside. So what I had to do is I had to reverse engineer every animated function like this, analyze the type declaration, and see how it's used, how it can be called, and then think myself how I can make the animation happen. And it's a very great approach. Again, it's very good that we have this stuff. But we are yet to build the documentation and tools around that to make it more easy to consume by beginners like me back in the day. So that was certainly a big problem. But luckily enough, Reason community is very special. Like, I don't remember being in a community that will answer every single question that I had on Discord under like a minute. That's like, if you have ever asked a question on Discord there, you will know what I'm talking about. And that helped me a lot. Because you probably know this feeling when you're trying out a new technology. You get stuck every half an hour, and you wait for an answer for 5 hours. It's like it's impossible to code like this. You get frustrated, you stop it, you throw it away. And that's what happened with me when I first started using Reason. So this is very special about this community, very encouraging. It helps you a lot. Problem is, there wasn't enough for me to feel confident about Reason. Like, I can't build my entire professional experience at my work based on asking people all over, because once, if they don't answer, I'll be just stuck. So decided to change that. As I said at the beginning, at CallStack, we have this mission of helping developers building their apps on many platforms. And so right now, we are using React Native because we believe this is the best technology for running our apps on many platforms at the same time. And as a leading consultancy in that space, we keep challenging ourselves every day, what can we do better to make our experience of cross-platform development even better, So we see Reason as a great opportunity to improve in few key areas where React Native might be struggling right now. And at the same time, we have few ideas that we have observed throughout the past 3 years building React Native in production that we believe could be very useful when connected with Reason. And as a last benefit, since we are working with clients that are actually running React Native, we have this great opportunity to promote Reason. We can just encourage our clients to do it And by that, we can contribute to the overall ecosystem and growth and adoption of ReasonML. And so we decided to change that, and we decided to come up with a project, and we call it a Rebuild. So Rebuild is an umbrella for many different projects around React Native and Reason. Once they are connected all together, we hope they will contribute to even better development in those technologies. It's a result of different ideas that we had and we experimented with over the past few months. So Rebuild, from the very beginning, has a very modular architecture. When we break it into pieces, Rebuild contains bindings to React Native, so that code that makes it possible to actually use React Native APIs. We have powerful and ready-to-use navigation. We have a very easy project generator that makes it easy to start. And we have a whole new CLI system. And we already started adapting Rebuild at ColdStack, so that whatever we open source to you is tested and doesn't contain a lot of issues, so that you don't get frustrated like we did back in the day. So in principle, we wanted Rebuild to be as easy to get started as possible. So let's take a look at the project generator. So in fact, the process of creating a new app with Rebuild is as easy as creating any other React Native app. Just show you a bunch of screenshots from GitHub showing many steps, but this is no longer true. We decided to stick to the current flow, which is about running React Native init. But by default, when you run React Native init, what you get is a React Native app with flow. So we decided to use a hidden feature of init that is called a template generator. And we can use it to tell React Native init to create a different React Native app than by default. So how many of you have heard of this feature before? Okay, quite a few. I know probably why, but that's what I'm saying. If you haven't heard about it, don't freak out. In fact, there are many hidden other features in React Native that you can just find out by reverse engineering a bunch of different code paths. Anyway, template generator is there to allow this particular use case. So to start using it, we can set a template flag at the end of our command to tell it to use that template. So what happens when you run a React Native init is to scaffold a new app, it goes through the existing predefined boilerplate. In this case, by default, we have two of them. We have the navigation template and the Hello World template. So the Hello World template is the one that you get by default. When you init your app, you get a blue background, some welcome to React Native experience. This is where it's defined. And so it works by just copying and pasting those files to your source code and installing dependencies. So that way you get an out-of-the-box experience automatically. And in order to use Rebuild, on the other hand, you again have to run React Native init with the Hello Chain React, for example, name, but you have to pass template flag and Rebuild as the name of the template. And the generator will attempt to install the React Native template Rebuild, which is, again, just a template that contains the Hello World application with the steps that we did for you automatically. So you don't have to think about all the different configuration to set up. You got everything in place. The only step that you have to do manually is that you have to go to your package.json and you have to modify the scripts so that the running experience is even easier for you. We are working on making that automated as well. Partially, the reason React Native init didn't do all the things that we wanted is that it's not popular. And the reason why it's not popular and you don't know about it is that its scope of features is very small. You can just copy and paste files. So our idea is to make it a first-class feature in React Native, propose an RFC so that you can also use it, maybe even internally, to scaffold applications and just to help you in general React Native development. So let's talk about bindings. Rebuild is based on BS React Native, as I said, and it's all about exposing bindings to React Native. In other words, it's just a wrapper around the JavaScript APIs. Unfortunately, that means that for now, running Rebuild requires you to spawn actually two bundlers at the same time. One is the Metro bundler that you already know from React Native, And the other one is the BuckleScript build system that will basically convert ReasonML to JavaScript and make it possible to be accessed. And the focus of the first iteration was to make sure that all the APIs and components are exposed in as most accurate fashion as possible. And so, to make it possible, we implemented the missing parts, and we also shipped documentation so that you can get started very easily. And the documentation itself shows usage of almost all components and APIs in Reason. So you don't have to get stuck and think like how you can use them. You can just glance the examples that we did for you, and you'll be pretty much set up. And so the principle that we had for Rebuild version 1 was to we aim for evolution instead of revolution. And so if you've been already using VS React Native or any other wrapper with written in ReasonML, you should be able to just migrate automatically without any issues. But let's start with a why. I mean, when asked about reason, or in other words, why would you even care about what I'm talking to you about today? And why would you like to introduce yet another abstraction to make React Native development even more complicated? I'd like to do it by an example because code is worth more than 1,000 words. So how many of you haven't used animated at all before? Please raise your hand. Okay, that's good because I have one slide that does a very short introduction. It's a very, very bare bones introduction, so chances are you may disagree with it to some extent if you've been already using animated. But animated module allows you to express your animations in a declarative way, and it all starts with creating an animated value, which is a holder for values that you're going to use for animation. And so, as a first thing, you give it a numeric value. In this case, it's a 0. Then you define an animation that is a function that will be changing the animation value so that we know how to change it, for how long, and what the end value will be like. And at the end, you start it. So now that we know where we are, more or less, don't worry, the examples are not even going to be using a lot of specific animated things. Let's do a small exercise. I will show you a few snippets, and your task will be to guess whether it's a correct code or incorrect operation. So let's assume that all the examples that I'll show you are like valid JavaScript as far as syntax, and that there are no flow errors at all. So in the first example, we are dealing with two animated values that we want to combine together. Okay, so we got a foo animated value and bar animated value, and we want to add them up together. Do you know what's the output going to be like? What's the value going to be like of those two animated values added together? Yeah, it's going to be 1, right? This is simplified, but eventually this is 1. So another example. We got two vectors, okay? One is a vector with 1 and 1 coordinates. The other one has 0 and 0 coordinates. Do you know what the result of this operation will be? Will it be an object with 1 and 1 when we summarize each property? Could be, right? That sounds sort of reasonable. Problem is, it's a string. Essentially, it's an object string. So it turns out vectors are not supported by animated operations, like interpolation, addition, multiplication. And it's a really interesting, undocumented implementation detail that you will find out just when you get this bug in production. And so with Rebuild, this operation is not possible. As you can see, we got type errors saying that the value xy cannot be an argument to the add operation. So that's how we can prevent those issues from happening at an example of Reason and its typing system. Another example also from animated module is about having one animated value and interpolating it to create another animated value. So interpolation creates a new animated value by mapping input values from one animated value to some other animated values. So long story short, if we have animated value that can have values between 0 and 300, we are mapping that to 0 and 1. And so we got this function, we are calling it, And does anyone know what the output will be? I'll give you a quick tip. Yep, it's gonna be red screen. We have really handy information by stop tracking function missing, which probably is not going to tell you anything as long as you basically try doing divide and conquer technique, and you end up just removing that snippet from your code base. And so we probably already know this. You probably already get this. Interpolated values cannot be animated. I mean, it's obvious once you start doing that, but I guess the first time you were doing animated, you would be like, what's going wrong? Like, what's wrong here? And so if you look at rebuild, this again is a type error. So your code will not even compile. This is a legal operation. And you got an error message saying that you basically cannot interpolate, cannot animate interpolated values. And this looks very dumb when it's like line below another. But if you have a function that receives animated value, you don't control what you're going to receive. So having a correct typing makes it sort of easier to operate across module boundaries and make sure issues like that do not exist in production. So this is by far my most favorite feature of Reason, and what really gets me excited about it, and what makes it different from TypeScript, Flow, and all other typing systems available within the JavaScript community, is that when you create bindings to a module, you have this ability to think about the API and maybe change it in some places. You can add some sugar, you can add some wrappers, and you can make sure that certain issues do not happen. And that's why we were able to get rid of those animated typing issues by adding few different kinds of animated values and making sure certain operations are not possible in between them. Another important part of Rebuild is its default navigation system. It started a while ago as bindings to React navigation, but we soon observed that there is way more than we can do to make a performant navigation for ReasonML and for React Native in JavaScript as well. And so it has a couple of differences from what you would normally expect from a regular JavaScript navigation system. One is that it has a native performance. Thanks to React Native gesture handler, all the gestures that you're going to use within your app are running on a native thread, meaning that none of your logic will ever make your gesture struggle anytime. Another big feature is that it has a fully declarative interface. And so if you look at the code snippet, you don't have any static configuration. Everything is part of your render method. So if you ever had issues with changing the state of your navigation based on lifecycle of your components, say header button changes when you press it, like edit mode, this is no longer hard. You just need to use your state, and in this example, you just have to return an appropriate icon based on the state of your component. And it's also super easy to implement or change or provide custom animations. They are also part of your render method. So it's as easy as defining, for example, fade vertical as a part of your render method to have a model-like experience without any hacks. Animation itself is an object that has this beautiful type declaration that looks a bit strange at first. But what it says that it contains a function for cart and for header interpolators. Looking at the example reveals that function is just a function to use for animating. In this case, we want to use a spring animation, which mimics the iOS mechanics, so that the animation looks almost real. And then we got the interpolators, like in this case, we want the slide from left to right animation, so we can use the translateX property. And so the navigation itself is still pretty much in progress. The features we implemented are working for us, but we are looking forward to collaborating with you on that to make it even more production ready so that it works for your use cases as well. And so I got the last part, which is, I guess, the most exciting, but I'm running short of time, so I'm really sorry that I will have to, speed it up. But yesterday, or 2 days ago, at the speaker's dinner, Gant said that if I'm going to need some time when something goes wrong, I could tell him to buy me 5 minutes. So I'm going to ask him if he can sell me actually 5 minutes, the other way. I'm not sure if that's possible. Anyway, the last part of Rebuild is the whole new CLI system. And if you've been following React Native, you know that I'm always excited about command line tools. Like, this is the first React Amsterdam conference where me and Alexei announced RNPM, which later became a React Native link. And we used React Native link to avoid this experience of linking all the stuff everywhere so that it's just as easy as running a single command and you can forget about all the native stuff. But link was just the first step. What we wanted to achieve was a completely standalone system for managing your React Native apps without touching native code. And so we never actually finished that because we got busy with other React Native stuff, but we'd like to use ReasonML as an opportunity to do this approach once again all over. And additionally, we'd like to abstract away native code so that working with React Native feels like working with Expo or Create React Native app. You still got all the code in place, but you don't have to deal with any native code. And just to summarize it, this may all sound really crazy or really weird, and you may be wondering why we are trying to divide community or something. Truth is, we are not. We have this compatibility principle, and regardless of you loving Reason or not, believing in it or not, all the ingredients, all the 4 ingredients, maybe except for the bindings, are gonna be available for React Native anyway. So even if you're not planning on using Reason, you will still be able to benefit from those features. And so all the bits and pieces that we are working on are MIT licensed and are available on our GitHub, so you are more than welcome to join us on that journey and help us make this development a better experience. This is our Discord channel, where we offer free support to all our open source libraries and where we actually keep discussing the future of React Native and Reason. And we would love to have you on board. We would love to hear your experience working with React, working with native modules in production, and essentially everything that you've ever done in React Native is of our interest. So please join this channel or just let me know in the most convenient way for you how we can help you and how we can make together Reason and React development even better experience. Thank you very much.